That video is actually for teacher. That video that talks about the theoretical value, yes, it's actually for teachers. It will guide the teacher to know the range of endpoint he or she is to fall within. That is for that video. But for this, we'll be talking about the salt for the titration, the acid for the titration, and the salt for the salt analysis, which is the qualitative what analysis. Now for the titration which is under the quantitative analysis. So let's begin with the what, with the titration, which is the quantitative analysis. In bracket we have the what, the titration or the volumetric analysis. Now the base that is given to us is what, is NaHCO3. Now this is sodium hydrogen triisocarbonate 4. Sodium hydrogen triisocarbonate 4. Now this base, this is the base, is acting as what, as the base. And they can ask you in your number 3, you know, chemistry practical in WAEC is usually number 1 is titration, number 2 is the salt analysis, then the number 3 is general. They just pick from different aspects of chemistry in general. Now for that number 3, they can ask you what type of salt is this. This is an acidic what, salt. Acidic salt is formed when there is insufficient base to neutralize the acid, or acidic salt is formed when the hydrogen ion of the acid is partially replaced by a metal. That is how acidic salt is formed. Now that means during this formation, that means what I just said is that during this formation, the acid here is H2CO3 plus NaOH. Now during this process, the hydrogen ion of this acid here, the hydrogen ion of this acid, you know, on ionization, if you write the ionic equation of this acid now, it will give you H2CO3. This one with this is the acid. It will give you 2H plus what, plus CO3, 2 minus aqueous. Do you understand me now? Now if you look at this now, we said I just defined this. This is an acidic salt, of which I'm talking about, an acidic salt. I said that it is formed when the hydrogen ion of the acid is partially replaced by a metal. Now, this is the hydrogen ion of this acid. This hydrogen ion is partially replaced by this metal here. This is, if you write this one will become Na plus OH minus. This is the metal here, sodium hydroxide. This is sodium. Now, if we talk about basicity of the acid, when we talk about basicity of an acid, what is basicity of an acid? We said that basicity of an acid is the number of hydrogen ion that can be replaced in one molecule of the acid. Now, the number of hydrogen ion that can be replaced in this acid is what? Is 2. That means the basicity of this acid here is what? Is 2. The basicity of H2CO3, the basicity is 2. So since the basicity is 2, we call it what? It is dibasic. Because the basicity is 2, we call it dibasic. How is it 2? Because it have 2 hydrogen what? Ion. Now when these 2 hydrogen, when one is replaced, the other one is not replaced. That is what leads to what? To acidic salt. Because I said it is what? When the hydrogen ion of the acid is partially or incompletely replaced. So now, if we write this one now, we are going to have what? NaH, then we have our CO3, plus what is left? H2O will be left. Are we together now? So if you write this one like this, it's going to give us NaHCO3, then H2O will be left. Now, if you look now, you see that this, like what I explained here, these 2 hydrogen, one have been replaced, but there is one that is not yet been replaced now, right? So if you now react this one with another sodium hydroxide now, it will give you what? Na2CO3. So if you completely neutralize this acidic salt, it will give you a normal salt, Na2CO3. So this is just by the side. This is not even what I want to talk about, but explanation took me to this part. So that is for that. Now let me now go back to what I want to teach you, to what I'm talking about. Like I said, it's an what? As acid what? Acid salt. It's not a normal salt. You know, we have a basic salt, a normal salt, double salt, and all of that. So, but this particular one is an acid salt. Then the acid they gave to us is what? Is HCl. Aqueous, aqueous. Now, the acid is what? HCl. This is how you prepare your solution. This is for teachers anyway, but students can as well learn from it, but the main purpose is for teachers to know how to prepare what? Reagents. How do you prepare reagents for, how do you prepare this reagent for your titration? Now, for you to accurately prepare your solutions, this is what you do. Now, according to this guide, according to the guide we have here, it says that we should measure, okay, okay, it says that we should measure, I hope you can see what I'm doing here. We should measure 8.0 gram of this. So what do? You get your weighing balance. This is sodium hydrogen triisocarbonate 4, not sodium triisocarbonate 4. They are not the same thing, sir. Yes, they are not. So please, if you don't have this one, because this one is common in most chemistry laboratory, if you don't have, please request for it. Go and buy. It's everywhere. Just go and buy. Go to any chemical shop. Tell them you need sodium hydrogen triisocarbonate 4. Please buy it. Use what it is. Use what is requested. So now you get this salt. They say measure 8.0 gram. So you carry your weighing banner. So I have this here. There are other type. Anyone you have. So you put it on. Like I don't like pouring the salt on this place directly. I don't like pouring it, and it's not even advisable. So what you should do is to get litmus, filter paper. So you get this filter paper. We are told to measure 8 gram, right? And before you even do that, before you start measuring your 8 gram, now this is, we are preparing B. B is the base, which is the acid salt. This is the salt, B. Then you get your 1000 ml volumetric flask. Then please make sure you wash it very well. You rinse it with distilled water. I have not started preparing my solution, of which I will do that first thing Monday morning, to teach my students before we prepare another fresh one for the exam, because the exam we can't prepare it and keep it till that period. It's not advisable. It's not good enough. So I will first of all prepare to educate my students of likely questions and likely things that will come out. Then I will prepare fresh one for them that morning again. So now you wash your materials very well. Well, mostly this one, but most importantly, you wash this one very well. Then you rinse it with distilled water. After you have done that, for your, okay, I'm holding A. So this is, I should be holding B. So this is actually B. Then before you start weighing, you have filled this 1000 ml, have filled it with what? With distilled water. Have filled it with distilled water. You know it is 1000. You can measure 504 here. Keep it after you have poured 500 distilled water there. Then what do you do next? You carry your weighing machine or your weighing banners. Then you set it at gram, because in chemistry most of our measurement is in gram, not kilogram. You set it in gram. Then you place your filter paper. It will read. So let's assume your filter paper read, I did not on it. Let's assume it reads 0.6. Then you open your calculator here, you press 0.6, right? 0.6, punch it here. You see plus 8 gram. You add 0.6 plus 8. It will give us 8.6. Then after that now, you keep it here. You take your spatula. Then you take your salt, you open, you start putting on the machine. Start putting once, and while you are putting, the machine is reading. It's reading 7.5, 7.7, 8, 8.1, 8.2. Once it gets to that 8.6 you have in your calculator, because you have added the weight of the filter paper to the weight of this 8 gram, everything will give you 8.6. So once it gets to 8.6, stop, carefully fold it this way, carefully, then you open it, then you carefully pour and make sure every drop falls in here, because you have already measured. Any little one that leaves, it will affect it. So you make sure everything goes in. So having done that, what do? You gently shake. You shake until it dissolves. Once it dissolves, what do you do next? You carry your distilled water, you fill it till it gets to this mark. There's a mark here. Look at where the mark is. So that mark is the 1 dm cube, which is 1000 cm cube. So once it gets to that mark, please, you stop. Then you have prepared your solution B. That is as simple as that. So now you have prepared that one. Then for your hydrochloric acid, which is the solution A, how do you prepare it? If you check your instruction manual, your guide, the one WAEC sent to your school, this, once you check it, you see that they say you should measure 8.6 cm cube of hydrochloric acid, concentrated hydrochloric acid, not diluted, concentrated. So you measure 8.6 of the concentrated using your measuring cylinder. So I didn't bring it out. Okay, it's not here, and I don't even know. I think it's somewhere. So you use your measuring cylinder. It's very small, but this one is just a test tube, but it's just a bit. You will see it. It have where it can stand. It have height what it can use to stand. You also have little where you can fetch. Just measuring cylinder, yeah, but very small like this. So measuring cylinder. Then you use that measuring cylinder is 10 mil measuring cylinder. Is 10 mil measuring cylinder. Then you use that 10 mil to measure 8.6. You look at it, you gauge it 8.6. Then while you are doing that, you must have taken another volumetric flask. You have filled it with distilled water as well. Then the 8.6 you have measured, that concentrated acid you have poured inside the measuring cylinder, that 10 mil, you measure 8.6 from the instruction. Then you pour it here to meet the distilled water here. You pour it, make sure every little drop have entered. Then after that, then you shake it, you shake it, you shake it, you shake it, you shake it. After shaking for a while, fill it with distilled water. You now add more distilled water for it to get to this mark. Once you get to this mark, you have prepared the acid. It's as simple as that. It's as simple as that. And having done that now, what indicator are we going to use? Now, this one will serve as a weak base. This is a weak base. And this is a what? This is a strong acid. This is a strong acid. And what is the indicator we are using? We are using methyl orange. The indicator we are using here in this titration is methyl orange, because the titration is between a weak base and a strong acid. And do not use more than 2 drops. Do not use more than 2 drops of methyl orange. Or mass, if worst come to worst, maybe 3, but it's advisable just 2 drops is okay. But mass, you can make it 3. But some people, I see some people pouring 4 drops, or 5, it's not advisable. Mass 3, preferably 2. Okay, having done that, you carry out your titration diligently. You will see that the end point will fall between 20 to 24 or 25. Thank you very much for watching this video. I remain blessed.